Hi guys, you are welcome once again to the Smart Way lectures on the Science Ambassador series. This is a series of lectures we are running on all the areas in science. Today we are here with you to continue on thermochemistry, and in this lecture we are going to help you solve some questions to be able to understand the concept we have done earlier. Now this is the question. The first question says that construct equations representing the standard enthalpy of formation of this. Construct equations representing the standard enthalpy of formation of this, and that is the alcohol, and then the sulfuric acid, and then the water. So we are just going to write the equations that are involved, and to do that you have to know what is the standard enthalpy of formation. We said that standard enthalpy of formation is the enthalpy change when 1 mole of a substance is formed from its constituent element, okay, in their definite state, okay, under standard conditions, okay. That's the enthalpy change. So we are going to look at that. So quickly let's write that equations. The first one, that is the solution. First one, we are trying to produce 1 mole of ethanol. Remember, it is standard enthalpy of what? Formation. And so formation is producing 1 mole of ethanol. So I want to produce 1 mole of ethanol. I want to produce 1 mole of ethanol, or I want to produce ethanol. And so I have this. The formation of this means that it is a product that has been formed. So I have my ethanol here, and I have produced my ethanol. And in the definition it says that this is formed from its constituent element. We have 3 elements here: carbon, hydrogen, and oxygen. And carbon here exists at ordinary condition or at room temperature condition as a solid. If you don't add this one, you are wrong. You have to indicate the state by which you are combining it. And then hydrogen at its ordinary condition or at its definite state, it exists at what? As a gas. So hydrogen exists as a gas. So for hydrogen, in its definite state, it exists as what? Gas at room temperature. And then you add oxygen to exist as what? Gas at room temperature. Okay, that is at room temperature. That's their definite state. So this is what they ask you to do. But you see, there's no equation without balancing. There's no equation without balancing. So you should be able to balance it. And to balance it, I said that you have to begin with the carbon first. 2 carbon is here, and so 2 must be here. Have you gotten that? And then total of hydrogen is 6 here. 5 plus 1. Have you gotten that? So we are going to get 6. 5 here plus 1 here, we are going to get 6. And the 6 here, I have only 2 here. So therefore, if I want 6, I multiply here by what? By 3. Okay. And here I have only what? This carbon, I have 1 over here. This oxygen, I have only 1 over here. And so here, oxygen here is 2. So if I want 1, I'll divide here by what? By half, so that I can get my 1. Have you gotten that? So this is what they ask you to construct. So this is the equation for that. This is what they ask you to construct. So first of all, you have to know that the enthalpy of formation is the amount of energy change when 1 mole of a substance is formed from its what? Constituent element. And these are the elements: carbon, hydrogen, and oxygen. And this element must be in their definite state. Okay. The next one, that is the B. The B part of the question is sulfuric acid. So we are going to write sulfuric acid. We are going to form sulfuric acid. We are going to form sulfuric acid. Then I'm going to get H word 2 O, and then this. Okay. Remember, this one comes in the form of a liquid. It's very important to write the state. Okay. So this also in the form of a liquid. Come in the form of a liquid. And then there are 3 elements here: carbon, sulfur, and what? Carbon, sulfur, and what? And oxygen. So at the definite state, carbon exists as a gas at room temperature. It's very important to add the state. Okay. And then the sulfur also exists as solid at room temperature. And then the oxygen also exists as what? As gas. And then oxygen also exists as what? As gas. Okay, so write the state. Have you gotten that? So there are 3 constituent element that forms sulfuric acid, and these are the definite states at, that is their state at room conditions are what we the same as the definite state. And you have to do that, and you have to be able to balance it. Hydrogen here is 2, hydrogen here is 2, sulfur is 1, sulfur is 1, oxygen is 4 over here, oxygen is only 2. And so if I need 4 over here, I'll just multiply here by 1, by 2, and then I'll get it. So this is what they ask you to do. Okay, for formation reactions, they are saying formation reaction, it must be formed from its constituent element. Then the last one, C, is formation of water. We want to form water. So water exists in the form of a liquid. So we have to put the liquid state here. And there are 2 elements that forms water. We have hydrogen existing in the form of a gas, and then combining it with what? With this. Oxygen also exists in the form of a gas at room temperature conditions. Okay, so if you balance it, hydrogen here is 2, hydrogen here is 2 over here, oxygen here is what? 2, here oxygen here is 1. So if I want to reduce here by 1, I'll divide by what? Half. Have you gotten that? So this is the equation that illustrates, or that can be used to represent the standard enthalpy of formation of these 3. So this is the answer to the first question. Okay, first question. Let's go to the second question. That's question 2. Question 2. It says that, what do you notice about the equation? What do you notice about the equation for the standard enthalpy of combustion of hydrogen and the standard enthalpy of what? Formation of what? Water. What do you notice about it? So let's write it so that we can notice what is happening there. Okay, so standard enthalpy of combustion. So it means that combustion means that we are burning it in what? In oxygen. Okay, so we are going to get this. I'm burning the hydrogen in oxygen, and hydrogen exists as a gas. That is the state of hydrogen, and I'm burning it in oxygen. That is combustion. Combustion means that we are burning a substance in oxygen. So when I'm burning in oxygen, what am I going to get? I'm going to transform the oxygen and the hydrogen to what? To this. That is, I'm going to get a liquid out of it. Okay, I'm going to get the water out. So water will come out from that. So that's what they ask. So state what do you notice about the standard enthalpy of combustion of this? And so this is the equation that illustrates the combustion when 1 mole of a substance is burned in what? Excess oxygen. And here you have to make sure that you have to balance the equation, and just as we wrote it from the top, this must be half in order to make sure that oxygen is 1 here, and here oxygen is 1. Hydrogen is 2, that's why I'm not focusing on that. Now, what do you notice about that? Let's also write the standard enthalpy of formation of water. So formation of water, we just as we did that, it is just the 1 mole of water formed from its constituent element, and just as we've written that the constituent elements are hydrogen, gas, hydrogen which exists as gas at what? Room temperature, and then also we have what? Oxygen. Okay, there are 2 elements that form water, and the constituent elements are hydrogen and oxygen, and in their ordinary state or in their definite state they exist as what? As gases. And so to balance the equation, I have to put 2 over here, that's 1 over here, half over here, in order to reduce these 2 by what? 1, so that I can get here 1 over here. Hydrogen here is 2, hydrogen here is 2, so I don't need to waste my time. And then please, always when you write, you have to write the state. Okay, you have to write the state. Here is what? Is that? So it's a liquid. So water is a liquid. We all know water is a liquid. And then this hydrogen and oxygen are all gases. So I've written the GG under. Go. What do you notice about it? So the first one I wrote was a combustion. So there is a combustion. So this one was a combustion. And then the other one was what? Formation. That is formation. Have you gotten that? So the other one was formation. The second equation is formation. So what do you notice about the 2? Now we can say that the 2 equations are the same. The standard enthalpy of combustion of hydrogen is the same as the standard enthalpy of what? Formation of water. And so here the same energy will be required for the combustion and then the formation. Have you gotten that? The standard enthalpies are all the same. the standard enthalpy of combustion of what? Hydrogen gas over here is the same as the standard enthalpy of formation of water from here. So the energy required for the two reactions will all be the same. Have you gotten that? Since the moles are the same and the states are the same, the energy required to what? To blast the or combust the hydrogen gas is the same as the energy required to form the water in the second equation. Now, good. So the second question says that the standard enthalpy, what do you notice about the second question says that what do you notice about the standard enthalpy for the combustion of carbon and then the standard enthalpy of formation of what? Of carbon dioxide. So let's also write the equation and see what the difference is. Okay, so here that is the first one is combustion of carbon. So carbon solid combusted with oxygen gas in XX, and what are we going to form? We are going to form carbon dioxide. That also comes in the form of a gas, and then that is the first one. That is the combustion. And then the other one is the standard enthalpy of combustion of what? And that's the standard enthalpy of formation of what? Of carbon dioxide. So we know that formation reaction, we have to write the product first, because we have to write the product first for formation of what? Carbon dioxide, and so that you can know the elements that are there. The elements are carbon, which ordinarily come as what? As a gas, and then we also have oxygen, which also exists as gas at room temperature conditions. Have you gotten that? And so this is what the formation of what? This is the formation of carbon dioxide gas, and this is the combustion of this. What do you notice? It is all the same as the first one. That one, the equations are the same, they are in the same state, and they result in the formation of the same product. Have you gotten that? And this, and the energy that it will require, the energy will also be the same. In that case, the energy, that is the enthalpy of the standard enthalpy of combustion of of solid carbon, okay, that is of solid carbon, will be the same as the standard enthalpy of the formation of carbon dioxide. The energy value will all be the same. In the first instance, to the same thing. The standard enthalpy of combustion, of the hydrogen gas, which is 1 mole, the same energy will be the same as the standard enthalpy of formation of what? Of water. Have you gotten that? So the standard enthalpy of formation of water. So what do we notice? We notice that the two equations are the same. They involve the same reactant and product in their definite state, and the energy value for the two, okay, are also what? The same. That is it. Now let's do the last one, and then we'll move to the next one. So now let's do the last one. So in this one, it says that's question 3. It says that calculate the standard enthalpy of combustion of ethane given the following data. Calculate the standard enthalpy of combustion of ethane given the following data. So I have the standard enthalpy of formation of water to be this value, and the standard enthalpy of formation of carbon dioxide to be that, and the standard enthalpy of formation of the methane to be this. And so let's write what the problem is. So let's write the problem. Solution. The problem is, they say that calculate the standard enthalpy of combustion of ethane. So this is the standard enthalpy of combustion of ethane. Ethane is a 2-carbon compound with 6 hydrogens. We did organic chemistry, and by this time you should know ethane. And to write the equation for the combustion of ethane, it is what? You burn 1 mole of ethane in XX oxygen in excess oxygen, and then all the carbon will break toward carbon dioxide, and all the hydrogen will break toward to water, okay? And all the hydrogen will break toward to water, and that will be a gas. And here will also be what? A gas. Here will also be a gas, okay? There will also be a gas. And here methane comes as in the form of a gas. So ethane exists also in the form of a gas. So this is what they asking us. Combustion, they say that calculate the standard enthalpy of combustion of ethane. And for ethane, okay, the combustion of ethane is represented like this. That's what it is, okay? And to do that, I told you that the enthalpy chain for this reaction, which is specifically this combustion reaction, okay? This combustion reaction, sorry, this is not formation. So this combustion reaction, okay, is the what? Is the enthalpy, okay, is the sum of the enthalpy of formation of all products minus the sum of enthalpy of formation of all reactants, okay, of all reactants. We use formation to calculate combustion. And so therefore, what do we have here? We have how many products? We have 2 products. So the standard enthalpy of formation of the first product, which is this, we have to balance the equation, which is very important. I'll balance it and I'll put the moles that are there. And then the standard enthalpy of what? Formation of what? Of water. Standard enthalpy of formation of water. Standard enthalpy of formation of water. That is the standard enthalpy. That is, this symbol represents standard. So standard enthalpy of formation of water, all minus the sum of all the what? Energy of the what? The reactant. So that is also the same. The standard enthalpy, that is this symbol for formation of the first reactant, which is the ethane, C2H6, okay, and then plus the standard enthalpy of formation of the oxygen, okay, of the oxygen, okay. So this is what they asked us to find, and in our last lectures we did it. Now let's quickly balance the equation. And here it is 2 carbon. I said that in balancing the equation you should always start from carbon first. So carbon here is 2, and here I have to put 2 here in order to make this carbon here 2, and I have to balance this. This is 6 over here, and so I have to make sure that the product side is also 6. We have only 3 over here, and we have only 2 over here, and I want to make here 6. So I have to multiply here by 3 in front, and I get 6. And then the last one, I balance the what? Oxygen, okay. So for oxygen, how many oxygens are here? 2 times 2 is 4 plus 3, okay, multiplying this oxygen here, which becomes 7. So there's 7 overall over here. 7 oxygen overall is over here, because 2 times 2 is 4, and then this 3 will also go and affect here. So the 4 plus 3, it is what? 7 oxygen, 7 oxygens on the what? On the product side, and then I have only 2 over here, but I want 7. So what I'll do is that I'll multiply it times 7 over 2. Okay, I'll multiply it times 7 over 2. Since I have only 2 there, I can multiply it by 7 over 2. So if I have 7 over 2 divided by, that is 7 over 2 times 2, okay, this 2 will cancel this 2, and I'll have 7 over here. So this is the trick we use. So that is what it is. Now to do that, we have to do that. Now that we have balanced the equation, we should be able to put the quantities of the substance that are formed. It is very important, because in the characteristics of enthalpy chain, we said that the amount of substance is proportional to the what? The enthalpy chain is proportional to the amount of substance. So use the moles in front of the what? Of the reactant and the product, and multiply it times the enthalpy values, okay. So here I'm going to make sure that here my carbon is 2, so I have to put 2 over here, and then my water is 3, so 3 over here, very important. And then oxygen is what? Is 7, so it's 7 over 2 over here. I have to make sure that I'll do that. 7 over 2 over here. And then the last one, I have carbon, methane, this one, ethane is only 1, so 1 over here. So the moles should come in front and should multiply the value that is given. So looking at the equation, okay, you can say that, looking at the equation, they've given us all the values we need, okay, So therefore, we are just going to what? Multiply and then subtract, and then that's all, okay. I have my carbon dioxide over here, so this is my carbon dioxide, and the value for the carbon dioxide is 2. But since I have 2 here, I'll multiply here 2 times the value, okay, negative 393. Have you gotten that? And then negative 393, and then I'll add it to what? The water. And this is the value for water. Okay? This is the value for water. So what do I do? And here is 3, so I multiply the 3 times the value. So you see how I'm using the respective moles. I'm multiplying times the value. So I'm going to get negative 2, 3, 6. Okay, I'm going to get negative 2, 3, 6. And then that is for the product side. Now let's go to the reactant side. The reactant side, I have ethane here. Ethane, this is the formation of ethane, this is the energy. And it's only 1 mole. Here is only 1 mole. So there's no need to multiply anything times it. So I'm going to get negative 85. Okay, I'm going to get negative 85. And then I'll add it to what? Oxygen. And here oxygen is not given, because you see in the standard enthalpy of formation of elements, okay, the standard enthalpy of formation of what? Substances in their standard state or in their definite state is 0. Have you gotten that? The enthalpy of formation of elements in their standard state is 0. So for example, for the enthalpy of formation of hydrogen gas, okay, is 0. Carbon as a solid in its standard state is 0, and oxygen in its standard state is 0. For elements, their standard states are all 0. The energy required to form them are all 0. Have you gotten that? So here, I'm going to just do the 0 there. I'm just going to add the 0. Okay, here the value for this is 0, because elements in their standard state is 0, or in their definite state is 0. So when you do the calculation, finally you will get this negative what? 1560, okay, kilojoules per mole. Okay, negative 150 kilojoules per mole. So that is what you get. Okay, that's what you get. Now in our next lecture, we'll be looking at the enthalpy of neutralization. Thank you.